Today, we're going to expand on the concept of cultural control that we briefly covered in our first webinar on the 10 cardinal parameters of plant health and vitality, and take a deep dive on IPM and IMM. Cultural control is environmental control, and it's the foundation of any comprehensive IPM plan to manage the pests and microbes present in your cultivation space. It is also the oldest IPM method, but was largely abandoned with the advent of chemical pesticides. The bioecology of the indoor garden was not well understood, creating inconsistent results. Chemical pesticides offered a more reliable and less knowledge and skill-dependent solution. But as consumers' desires for clean, pesticide-free cannabis increase, and the toxicity of pesticides becomes further scrutinized by regulators and a scourge on the environment, there is renewed interest in cultural control. Only recently has the pathogen-host environment relationship been understood well enough to harness the power of cultural control to boost secondary metabolite and biomass production. It also serves as a potent risk reduction technique to prevent pests and pathogens and allows cultivators to produce consistent, clean cannabis cycle after cycle without the use of harmful chemicals. Just a quick note from the legal department. Due to the federal illegality of cannabis and the variability in state-by-state laws, we cannot make specific product recommendations for your IPM plan. As with previous webinars, we'll present for 30 minutes, then open the floor for 30 to 45 minutes of Q&A with a guest appearance by Robbie Batts. This webinar will also be recorded and available on our website early next week. Please use the Q&A button at the bottom of your webinar screen to ask questions at any point. With that, I'll pass it over to Jesse to kick us off.
Right on. Thanks, Brian. Appreciate it. And thanks everyone for tuning in on this topic. I'll be honest, it's one of the main reasons I'm so passionate about cultivating cannabis. When my mom was diagnosed with cancer, it was about trying to find her the best and strongest possible medicine we could. We went everywhere. We hit every dispensary, every medical outlet, and we purchased products that had mold and mildew. We purchased products that didn't burn right, purchased products that were clearly sprayed with pesticides. I remember one time I was smoking with my mom in the backyard, and she turned to me and she said, "Oh, this one's a sparkler." Snap, crackle, pop. The bud was doing things it shouldn't have, indicating that it had been sprayed with something, heavy metals, sulfur, something along those lines. It blew me. I immediately realized the importance of integrated pest management. And it's a controversial topic. There's personal choices, business choices, and legal parameters. But when I had my hydro shop, Oakland Garden Supply, we encouraged people to bring in leaves and media in a bag. We would put things under the scope and we'd look at them. We learned a lot. And the two questions I got more than anything else were, what is this and how do I kill it? And my answer was usually, are you sure you want to kill it? And what are we doing to prevent it? As a result, we became amateur entomologists, microbiologists, and chemists, all in a trial by fire. People would come in and want a solution directly given to them within 10 minutes. And then we would have to look them in the eye the next day and talk about how effective it was. So the idea behind this webinar was really to present the tools and share some of the experiences that I think will further the discussion on IPM and IMM for cannabis. So what is integrated pest management? It's about dealing with and living with and managing pests. Same with IMM, integrated microbe management. Treat them the same way. And I think it probably seems like an oversimplification, but the truth is I've used this triangle and this book to develop hundreds of successful IPM and IMM plans for gardens. The triangle on the left illustrates the progression from prevention to intervention. It starts with cultural control. That's the foundation of IPM. Cultural control is about creating an environment where plants thrive and bag bugs don't. And it's the only non-invasive option. Then we move to physical control, which is about traps, barriers, and the physical removal of pests. Then on to biological control, which is about deploying beneficial insects and good microbes to work on your behalf to eradicate pests. And then finally to chemical control, the application of items toxic to pests that don't kill the plant. The reason I love this book, Hemp Diseases and Pests, Management and Biological Control, is because it allows you to look up a pest and understand the progression that you need to take in order to eradicate it. But it's important to know the tools of the trade. When we really think about fighting pests and pathogens, it's important to start with good genetics. I mean, I think this is one of the reasons why so many people grew Blue Dream initially. It's a great yielder, it's hard to kill, even when it's covered with mites. But that's really not enough. We need to understand that growing healthy plants is a science, and these tools are going to help you refine the process. It starts with some sort of lighting meter, something to determine the energy that's coming into the space. Lighting, infrared, UV, they're all important. Then you need to think about the temperature and humidity of the ambient space. You need to think about some sort of tool to measure leaf temperature, whether it's a camera or an IR gun, so you can manage VPD, your vapor pressure deficit. Then you should think about measuring the gases in the space, specifically CO2. You'll need some sort of microscope to take a close look at bugs, eggs, and leaves. Sometimes you can even get away with a camera, a microscope app. Then you need some sort of water activity meter to determine whether or not your product is safe for final packaging. And lastly, one tool that I like to use is a refractometer, which essentially measures bricks in the plant. And this is a trick I learned from commercial gardens that grow grapes in Northern California, which is if you can get your bricks level above 12, it's going to be really hard for bugs to eat your plants. So the healthier plants we grow, the less susceptible they are to pests and pathogens. But it's also about creating the right culture. In this case, creating a clean environment. It's important to clean the garden space in between runs. Something like hydrogen peroxide or gases like ozone that really get into the nooks and crannies will help you eliminate the pest vectors. It's also important to remember to do this when the plants aren't in the room, because some of these products can have a detrimental effect on the secondary metabolites. Also, you need to clean filters, fans, fertigation lines, and those wild condensate lines. Who knows what's in there? You need to clean them. Clean the plant debris from the space. From defoliation, dispose of that properly. And also, I think a lot of people know this, but quarantine your plants, but also quarantine your media as it enters the facility. I like to treat every plant and every media that comes into my facility as if it were infected and deal with it appropriately. Then I think something that we've all gotten a lot more used to recently is that people carry pests. We have 10,000 microbes on each hand, and we shell 40,000 skin cells every single minute. So SOPs are important. Wear gloves, wear hairnets. Also, think about cleaning the ancillary spaces, like the bathroom. Employees use the bathroom. They go in, they play with their phone, then they wash their hands. But when they leave the bathroom, what's on their feet? What's on their pants? Are they bringing pathogens into the space? Think about the hallways, the mop sink. These are all vectors, and they either need to be cleaned with technology or with elbow grease. Also, think about cleaning the water. The water that comes into the facility is usually not the biggest obstacle. It's the recycled water. It's about standing water and making sure that standing water is treated appropriately, aerated, because if it's not, it's going to develop water molds that are systemic, and you'll feed them directly to your plants. So another way to remember it is start clean, stay clean, finish strong. So now that we have a culture of clean, let's talk about a culture of success. And that starts with scouting with a microscope, getting positive identification, taking appropriate action, and evaluating. It's a continuous cycle. Keep a log of the pests, keep a log of the conditions, the fertigation, the water into the space. All these things are important when you think about historical trends and how you're going to eradicate pests for the long haul. Speaking more about positive identification, this is so important to winning the war against the pests that threaten you. There's an entomologist that I love her work and I love what she has to say, Suzanne Wainwright Evans. She's, when she decides to publish her photo book on positive identification, I would spend whatever it costs to get that book, because positive identification is critical. Like I said, to a lot of people looking at this slide, they might think, man, look at all those bad bugs. But they're not all bad bugs. Sure, the majority of them are. But a cautious story, I worked at a facility in Oakland that was an outdoor facility, and I came into work one day and there was a petri dish filled with larvae and a note that said, "Jesse, please kill these bugs as fast as possible." And I sighed. I picked up the petri dish, I opened it up, I walked outside, and I sprinkled the ladybug larva all over the plants. It was an inappropriate identification of a pest. So it's critical that you know good bugs and bad bugs. Otherwise, you'll be trying to kill all the guys that are trying to help you fight the war. Positive identification of microbes is also important. This is a chance to bring in a microbiologist to talk about which microbes are good and which microbes are bad, which microbes you have in your compost tea, which microbes you have in your space. They can take samples and they can give you a really good idea of what you're working with. But furthermore, get to know your shapes and structures. Once you start to know this, you can really do an amateur evaluation and identification under a microscope. Another story of caution here when it comes to positive identification is I had a friend who had a 500 light facility, and he said, "Hey, Jesse, one of my rooms, we had catastrophic loss in week 4. Everything just died because of root aphids. Please come assess the situation and tell me how to kill the root aphids." I went to the facility, I looked through the media, I dug through the root zone, I looked at every plant I possibly could. I couldn't find larvae, I couldn't find eggs. Maybe I found some fungus gnats, but I sure didn't find root aphids. And then it hit me. You have Pythium. I could see it on the stalks of the plant. So I said, let's go look at your water source. So we immediately went to his water source, which is a 250-gallon tank outside of the room that wasn't aerated, wasn't treated with UV, wasn't treated with anything. And I could see the black mold growing on top of the water surface. And what I said was, all right, you're feeding your plants Pythium and they're gonna die. You're feeding them a systemic water mold that's going to kill them. That's the problem, not root aphids. So all the effort, all the time, and all the money you spent trying to kill root aphids that weren't there were just simply not effective. Positive identification is critical. So when it comes to positive ID, let's assume for a second that we've made one. We have mites and we have powdery mildew. But which mites? Are they carmine mites? Are they russet mites? Are they broad mites? Well, in this case, we have a picture of 2 spotted mites and powdery mildew. So now that we know who our enemy is, let's learn everything we can about them. Do every bit of research you can. Consult the Hent Disease book. Look at everything you can possibly read to understand how these things grow and live. So a little bit on powdery mildew. We know that it thrives in low light conditions with poor air circulation and excess nitrogen. We know it's spread by the air, and we know that it's spread faster in high humidity environments. And we also know that it's all around us. Spider mites, right? We know they feed on, these particular 2 spotted spider mites feed on chlorophyll-rich plants. The females lay 200 eggs every 8 days. They prefer hot and dry conditions. Cold temperatures cause hibernation, and the light cycle is going to impact their action. So this gives us the things that we need to know. What are the pests susceptible to? How do they feed? How do they breed? How do they move? Where do they hide? And how do we pierce their armor? Well, the first step is understanding how we prevent this infestation in the first place. So we need to understand cultural control. Again, for any pest, it's about creating an environment where they can't thrive. So how do we do that? Well, at InSpire, we model every room so we know where the air flows so we can create the right pressures. We remove oscillating fans and pocket dehumidifiers so they don't create microclimates or become the source of pests. Then it's about air cycling. Every 3 minutes, we try to cycle through multi-stage filtration. First, through a MERV 13 capture filter, which gets everything down to about 1 micron. Then through a photocatalytic oxidation process, which is essentially UV light shining on titanium dioxide, which creates hydroxyl radicals that function like a molecular shredder. Then, in-rack airflow will continue the airflow cycle by delivering the CO2-rich conditioned air without radical oxidative species directly to the plant stomata to break up the canopy, which further eliminates microclimates. And lastly, it's about control of the temperature, control of the humidity, when the lights are on, when the lights are off, and during the transitions. Swings in temperature and humidity create an environment for powdery mildew to take hold. And precision control will allow you to manage your VPD, your vapor pressure deficit, at every stage of the plant growth, which will help mitigate the risk of powdery mildew. It's also important to note, understanding light penetration, temperature, humidity, airflow, nutrient dilution, watering rate, they all play a big role in the formation and spread of powdery mildew. So get control of your culture and powdery mildew won't affect the bottom line. Don't get control and you'll need to prepare for a war every single flower run. So what's the next type of control? It's physical control. What could we have done physically to prevent the spread of this? Well, first let's check the air pressures and make sure that we have a positively pressured space. Let's check the SOPs and make sure that everyone is wearing gloves when they handle the plants. We want to make sure that your master gardener isn't playing with their pit bull before they come into the shop, and we want to make sure that house flies aren't entering either. Who knows where your pit bull was last night? And spider mites can hitch a ride on the back of house flies and get into your facility. So it's not the flies that are the problem, but they are the vector. So what's the solution? Amputate and remove leaves at the initiation of outbreak. We had mentioned two-spotted spider mites lay 200 eggs every 8 days. So by removing those leaves, we can remove a significant amount of eggs, sometimes a lot more than 200. But again, be careful, because if we remove too many leaves, that's going to affect the plant's vitality. The next stage of control is biological control, which really deals with the 3 Ps: predators, parasites, and pathogens. This is another opportunity to bring an entomologist to the party, but the resources are out there. It makes me think of my friend Charlie McKenzie and the Crop Walk team, who does an IPM audit. They'll walk your facility, tell you what biologicals would help you win the war. And in this case, we have two-spotted spider mites. So we might choose Californicus and Persimolis. They both work a little bit differently. They're a little bit different sizes, but they're both going to eat mites and eggs. And it's important to know, because if we think we're going to bring rove beetles in here, then they're going to live in the media and not on the leaf tissue and not be quite as effective for what we need. And then we can think about biological control with microbes. It's a chance for you to bring a microbiologist to the party to talk about which microbes are going to thrive in our space, how we're going to get these microbes. Is it teas? Is it ferments? Is it purchasing individual microbes? And if you take a close look at this slide, you can see we might choose Bacillus pumilus, which is a fungicide, Bacillus subtilis, which eats powdery mildew, Streptomyces, Trichoderma. There's a lot of choices here that we can apply from a biological standpoint to eradicate the threats of powdery mildew. There are also beneficial bacteria that consume eggs and ward off bugs. So it's a real option for you, but it takes an understanding of microbiology to deploy. Then the next step is chemical control. So this is the chance for you to bring another IST to the party, a chemist. And this chemist is going to tell us what's in every bottle and how it works and how it affects the plant. There's a lot of tough decisions to make here. Are we going to go with biorational insecticides? Or are we going to go with synthetic insecticides? There essentially are 2 main camps when you really break it down. The long-term prevention and eradication of pests fall into the oils and soaps category or the sulfur category. And one of the major reasons we differentiate the 2 is because we can't apply them both at the same time. It's not a matter of just going into the IPM cupboard, grabbing a bottle and applying it. We need to know how these things work as a synergy. If we apply oils, then we really can't apply sulfur within the next 14 days or we'll burn our plants. So it's an important consideration, the chemistry, the makeup, and how they impact the plant. All right, so which path do we choose? This is where it becomes a personal and business decision, and it gets really tricky. This is really about understanding the interaction between technology, the farmer, the market, and enforcement. There are a lot of things at play when determining the appropriate IPM strategy for your cultivation facility. It's a delicate balance of risk and reward, but it's also a personal choice that will affect the business bottom line. So legality, and this is something that Brian mentioned earlier, federally illegal, it becomes a gray area when deciding which pesticides and which biological control methodologies to deploy. Federally, there are no guidelines. State by state, there are varying guidelines. So it's important to know in your state what you can and can't use. And that's important because testing is the enforcement arm. So we need to know what's going to show up on a test, how it's going to show up, and what's the cost of that. So if you use a substance you shouldn't, or you use a substance that's allowed, but you use it at the wrong time, it will show up as a fail for residual pesticides. And that will be a compromise to the end product, and it will be a compromise to the brand. It's often very hard to recover from something like this. And next, in making this decision, it's about understanding the factors of influence. And I think a lot of times when we think about factors of influence, we think about doing a cost-benefit analysis. How does this system make sense for us? Where is the risk? Where is the reward? What are the costs? So it's about taking the historic IPM triangle and incorporating it into your business plan for long-term success. Understanding the modes of action, how things work, understanding the environmental considerations. How do they work in your space and how do they affect the spaces outside of yours? What are the application guidelines? What's the dilution rate? How much does it cost to use it? What are the timelines for efficacy? What are the timelines for your needs? What are the stages of development that you're encountering with your particular pest? What's the systemic acquired response? How are the plants going to respond to this? Can we prep them for a threat? And what are the synergies? How do these things work together? And I'll try and go through them really quickly. So, modes of action. There are a lot of different modes of action, and there are good resources out there that break them down in even more detail. But essentially, we're talking about how are we going to physically kill the bugs? Are we going to dehydrate them? Are we going to suffocate them? Are we going to get them to eat something that kills them from the inside? Are we going to affect their nervous system by either overactivating them or slowing their development? Are we going to prevent them from molting? Are we going to prevent them from developing into the next stage? And also, I think there's a great picture here in the lower right corner that if you've read Jeff Lowenfeld's book, Teaming with Microbes, or studied with Dr. Elaine Ingham, you'll know that this is a fungal hyphae that is strangling a root-feeding nematode. Pretty cool mode of action in my book. Then you have the environmental considerations, just like I mentioned. All the IPM and IMM decisions you make will either impact the environment or will be impacted by the environment. Your brand might be more well-received if you choose the least toxic path. But the application environment like temperature, humidity, and airflow can have a dramatic impact on management efficacy. If you're playing the microbe and biological angle, think about creating environmental conditions for them to thrive. Beneficials need habitat. They need a food source. They need appropriate temperatures in day and night so that they can breed and they can establish for the long haul. Also, think about environmental considerations for the chemistry you might use. For example, sulfur is going to be much more effective in a high humidity environment when the temperatures are below 80 degrees. In a dry and hot environment, you apply sulfur, you will burn the plants. Then you have to think about application guidelines. How do I apply this product? Is it a dust? Do I spray it on the leaves? Do I dose it in line? Where do I deploy the sachets of insects? What's the personal protective equipment I need for this application? What's the dilution rate? Per acre, per canopy, per plant? The math can get confusing. When do I apply it? Where do I apply it? In the root zone, the undersides of the leaves, the tops of the leaves? Well, for mites, we know we need to focus on the undersides of the leaves, and for PM, it's going to be all over the plant. But important considerations. Timelines. Timelines are of utmost importance as well. For reapplication, for toxicity, toxicity to the bug, toxicity to the plant. We need to understand the time that it takes the fungal hyphae to develop so it can strangle that root-feeding nematode. We need to understand how long it takes resistance to occur in the bug. We need to understand that so we know when to rotate the modes of action. We need to understand how long it takes the plant to build up defenses So we're building up the defenses to the utmost capability before these threats come. We need to understand how long it takes these applications to be effective. How long does it take them to work? How long before we judge whether that application was or wasn't effective? What's the half-life? How long does it work for? And what's the re-entry period for worker safety? How long do we have to wait before we can go back into the space and start growing? Another factor of influence is thinking about the stages of development. First, the stage of development of the plant, then the stage of development of the pest. We want to kill all stages of the pest development while considering all stages of the growth. So for something like our two-spotted mites, we're going to want an ovicide, a larvicide, a pupicide, and an adulticide. We want to kill them at every stage. For the powdery mildew, we want to think about something that's going to deal with the pustules, the spores, and the fruiting bodies. Important to consider all of those factors and deploy different mode of actions varied at different timelines to be most effective. Something to think about. Sulfur is going to kill powdery mildew and mites really well. But when you get into late stage flower, if you spray your Skittles with sulfur, they're going to turn into rotten eggs. So it's important to understand the stage of development, the application, and its impact on the final product. Then we get to systemic acquired response. And this is essentially getting the plant to fight back for you. It has natural defenses, and with hormones, acids, enzymes, and microbes, we can trigger the plant's natural responses. I love salicylic acid. It's a product that you can apply to your plant to get it more turgor, to get it more rigid, to have the plant be very strong and very hard to eat from a leaf tissue and a root zone perspective. Also, I love to apply seaweed or kelp. And one of the main reasons for that, outside of the fact that I love to eat seaweed, is it's filled with beneficial hormones in a very balanced application. Cytokinins, auxins, and gibberellins will all help the plant trigger its natural defense mechanism and fight off this plant. So in reality, or fight off this pest. In reality, what we're trying to do is prepare the plant for war at all times and allow the plant to defend itself naturally. And then that brings us to synergies. And this is about how the choices that you make interact with each other. How do they interact with the microbes, the beneficials? How do the chemicals kill beneficials? How do they kill the bad guy? How do they affect the plant? And again, synergies, sulfurs and oils, right? We can't spray them at the same time, otherwise we will burn their plant. How do your choices interact with your personal consciousness, and how do they impact the bottom line, efficacy, price point, branding, and the final product? At the end of the day, what I usually say is your IPM and IMM strategy will have a tremendous impact on how your plant grows. Every IPM and IMM choice you make has an impact on the pest, the plant, and the environment. The more that you can prevent, the less you'll have to intervene and accept the negative impacts physical, biological, and chemical control can have on plant vitality, yield, and quality of your finished flowers and extracts. I like to say, control your culture or it will control you. And what I mean by that is that a lack of control will necessitate consistent intervention and leads to inconsistent results. Physical, biological, and chemical control require training, and misapplications do happen, sometimes with disastrous results. Whereas proper cultural control has no negative impacts on the plant. It will never burn your plant, and it synergizes with every aspect of your cultivation operation. Cultural control is environmental control. It's the foundation of any IPM and IMM strategy and the key to consistent high-quality harvests. If you don't have good environmental control, you will always be battling pests, and you will never know how many grams per square foot or hundreds of dollars per pound it is costing you. And with that, I'd love to sort of jump into some Q&A. I tried to go through that pretty quick so we could tackle some real-world questions, which we saw a lot of come in before the webinar as well. But with that, back to you, Brian.
All right. Thanks, Jesse. Very nicely done, as always. We'll let the questions spool here for just a couple moments, and we can everybody take a quick drink of water, and we'll pull up our cameras and jump in just a moment.
Jesse, great job, man.
Thanks, buddy. You need a bow tie, Rob. Let me send you one up in Toronto.
No, forget that. No. You know what? I quit.
Looking good, bud. Thanks for joining me, man. I appreciate you.
Thank you for memorizing all those technical taxonomical names, because I'll never do it.
There's so many that I don't know. It's embarrassing, but it's good to know a handful.
Yeah. Very cool.
Good deal. Okay. Wait, let's get going on Q&A here. First question here from Ben. You didn't answer how I kill PM and mites.
Yeah, that's a great question, Ben, and I appreciate that. And it's something that I think definitely takes a conversation with the individual gardener on making the appropriate approach. But let me put it this way. It starts with cultural control. You need to have a clean space. And then the progression goes something like this, right? We need to get cultural control so we can prevent this from happening in the future. We need to get cultural control so the applications that we take are most effective. For me, I like to start with, if there's an outbreak, immediately go to physical control. Remove the leaves that you see being hot spots for possible vectors, contamination, and spread. And then it's about building this castle cell wall with microbiology. I had mentioned a handful of beneficial fungi and bacteria that work against powdery mildew and might work against mites in the space. But my feeling is it's all about diversity. Let's throw every beneficial microbe we can at this plant and see how she responds. Let's give her every tool in the toolbox. We don't know enough about microbiology in plants for me to say, this is the answer. Instead, I say, think about teas, ferments, read some good books that are challenging what we know and allowing us to really dive into different microbiological answers. Then it comes to an actual deployment of beneficial insects, right? So in this particular case, like, let's bring insects to the party, but what if we're indoors? Maybe that's not an option. Like, I don't want to burn a bunch of ladybugs and I don't want to clean up a bunch of dead carcasses. So same time, I'm thinking, give me diversity, give me as many beneficials as I can. Let's get them in the root zone. Maybe they're not a direct impact on that spider mite, but they're going to help us. Soil mites or rove beetles, beneficial nematodes, get them all to the party. So they can try and work for you 24 hours a day, the entire time, before we have to get to chemical. And then when it comes to chemical, I sort of tend to find myself in the oils and soaps category a lot. So I think about some sort of extract that might affect the mites as a nerve toxin, something like pyrethrin derived from chrysanthemum. I would mix that with an oil that would suffocate maybe another oil or an extract that would prevent breeding, prevent feeding, and prevent the larval development. So something like neem. Then we need something that's going to mix those things together and make them more effective as an application. So a surfactant like soap. And then I like a penetrant. I love penetrants to kill eggs, whether it's citric acid or alcohol or something of that nature. Now, when we think about what we just went over, oils, soaps, and alcohols, those are also really effective against powdery mildew. So that's a pretty good synergistic first pass of, hey, that's an application that's going to kill both of these things. It needs to be done appropriately with the appropriate dilutions at the appropriate timelines with the appropriate environmental conditions, but they are absolutely effective. And for me, it's really about understanding what the ultimate goal is, to get great flower. So if we can get environmental control, we can do preventative applications during the vegetative process, build the castle cell wall, and then in the first 2 weeks of flower, take action if we need to from a chemical perspective, and then kick back and let those plants develop without additional foliar applications that degrade our product and compromise our quality in the end. So sort of my approach there.
Yeah, thanks, Jesse. That makes a lot of sense. It seems like that IPM triangle has been sort of flipped on its head over the last few decades or so, and people start with chemical control, but it should be really reversed and started with chemical control first as a cultural control first as a prevention method.
And I think we're still discovering, right? When I had my hydro shop, everyone just wanted to come in and buy a poison. And I would say like, hey, think about talking to the beneficial insectary and seeing what they have available. Talk to Dragonfly Earth. Talk to Mammoth Pea. They make microbes. Research Dr. Elaine Ingham. Look at the soil food web. Take a look at Korean natural farming and One Straw Revolution. Look into these other methodologies that are historically viable and have worked for hundreds of years in other locations. Understand what's working for them and incorporate that, because it's so much more cost effective with so much less degradation to your product if you can take that approach of prevention before intervention.
Yeah, yeah, sort of a line of last resort with the chemicals. An interesting question, sort of parlaying on the concept of microbes and microbiology and pests from Anders. He's saying some growers seem to be taking a sterile, clean room approach to IPM, whereas others are utilizing natural defenses like biologics and beneficials. Do you think a hybrid approach of the two methodologies is achievable while being practical in day-to-day workflow and cost-effective in terms of production costs? Or do you think this approach will lessen the efficacies of both schools of thought?
That's a great question. That's a great question. And what I usually say is that every facility I've ever been into has pests. And there are cultivators out there that will attest to me walking to their facility and them saying, hey man, this room's really clean. Me flipping over a bug or flipping over a plant and saying, but what about these eggs? What are these guys? So in short, what I would say is it's really, really hard to have a perfectly sterile environment. And then on the flip side of that, there's a benefit to sterility, and I'm a big fan of trying to be as clean as possible. I think what happens is you get these two schools of thought and they think that they're diametrically opposed. And the reality is that yes, so many chemical applications, whether it's hydrogen peroxide and acetic acid with xeritol or some sort of other spray like sulfur, which is going to kill our beneficials, are not going to work with the microbiology. And that's true. And I used to say this all the time too, encouraging people that were using synthetic nutrients in their feeding schedule to incorporate compost teas. Look, those synthetic nutrients, some of these chemical poisons and toxins will kill microbes, but the strong will survive. So if we kill 60% of the microbes with our sterile approach, we still have 40% of the microbes that don't care about what you're throwing at them. So for me, yeah, I mean, there is a marriage in there somewhere that allows for realistic application of, a sterile environment and what it takes to do that, while at the same time embracing microbiology and beneficials. So there's a cost and benefit there, but yes, I think it's viable to blend the two of them. I think the more momentum you can build with microbiology and beneficials, the better. That momentum is what's going to carry you through those last 4 weeks of flower. And if you need to, you can apply some of these chemical sterile approaches, but don't be afraid to mix the two. See who survives and who the strongest ones are.
Well, Jesse, are the pathogen, can you guys hear me okay?
Yeah, you sound good.
Okay. If pathogen pressures are cumulative, does it make sense to do as much as you can all the way through the cycle, right? We go into rooms where they've got the pads full of alcohol or whatever, some other sterilizing media that you step in before you walk in. We see people gown up. I've seen that on smaller room grows. It can be a real hassle in terms of workflow. If you're going from one room to another and the movement is, the duration in a room is short, then it is really going to hamper your workflow. But when we go to large greenhouses, for example, they're going to be in this bay for 2 hours or 3 hours at a time. What's that break-even point? Is there a break-even point we've noticed in the facilities we've been in, or should we just be doing it all over the place?
Well, I think, again, it's sort of going back and referencing that triangle, right? It's about starting with a culture of clean. And what does it take to get that culture of clean and make decisions that are appropriate for that? But then when it comes to plant health, it's important to think about the stages of physical, biological, and then chemical. So just because you're trying to create a clean environment doesn't necessarily mean you have to exclude beneficials. We are trying to create an environment that doesn't have bad pests and pathogens, no pythium, no botrytis, no powdery mildew, no aspergillus. But those are not the beneficials we're bringing in. So for me, it's like, let's bring in some beneficials that work on our behalf. Let's try and keep the room as sterile and clean as possible. In between the rooms, gas the room to make sure that we don't have that vector. But at the same time, if you think that you're going to skip those first 3 steps of cultural, physical, and biological control, it will be very expensive to continue to apply the right chemicals and the right processes to make sure that you have a sterile environment. And in the end, you're probably not going to achieve it. It's so rare that I've walked into a facility and I thought, man, it's going to be hard for me to find a pest here. It's usually I just walk in and go to the mop sink or go to the bathroom or go to the doorknob and just like, hey, let's do a swab, send this off to the lab, see what comes back. And people are shocked.
Yeah. But I mean, pests are one thing. Like maybe there's a way to keep them all out, but you talk about microscopic microbes and the fact that we're shedding microbes off of our skin at such a high rate. I don't
Sort
see,
of a scary thought, right?
It's crazy. It's crazy to think about. I don't see how there'd be any way to really create an entirely sterile environment. So to me, it makes a lot of sense to foster the good microbes and the beneficial pests potentially, because it just seems like an impossible thing to achieve.
And I'll say this, though, I've seen a lot of developments in automation where we're trying to get more people out of that space, more items out of that space, more vectors out of that space. So instead of having someone come in that's wearing gloves and a Tyvek suit that's 4 inches too short on the arm, and every time they brush against the leaf, they bring on whatever's on their arm.
Mm-hmm.
You know, now we're trying to get to the point where it's like, should we automate this completely? Should we have sensors and cameras in the room telling us what pests are there, or where we have an issue in the canopy that looks different than the rest of the canopy?
Right.
Should we have, basically a running set of, mechanical scissors that come and trim up the cannabis appropriately? I've seen these things explored. And one of the reasons is because it's so hard to keep a room clean, and people coming in, they bring in their pests with them a lot of times.
Yeah. Gosh darn. It's, yeah, I mean, you got to do tissue culture to make sure your genetics are clean, make sure the media that you're planting the plantlets into are clean, that, there's zero interference from humans. And then, I mean, I guess I wonder also, if it's a sterile environment, what are you missing if you don't have beneficial microbes within your ecosystem? Are you growing the best plants that you can? Are you getting the terpene and the cannabinoid content and the biomass that is potential in the genetics?
Yeah, I think there's a whole another webinar of me blabbing on my soapbox about how great microbes are, but the research is out there and more is coming. The benefits, the yield benefits. I mean, a company that I look at is Mammoth Peat. They work with a lot of people. They show you how much more you can yield with the benefit of microbes. They show you how you can unlock nutrients in a different way. But then it's really embracing it from a synergistic, position where it's like, if you're just going to feed nutrient salts, do you have the appropriate cation exchange? Do you have amino acids? Do you have B1 vitamins? It's about thinking about plant health from a holistic perspective, and microbes play a role. Whether you like it or not, there are going to be microbes on your plant, even in a sterile environment. Rob and I have talked about this. It's like, well, maybe we bring hydrogen peroxide gas or radical oxidative species to the plant in order to make sure that the plant's sterile, right? But the reality is that's probably going to wipe out the beneficial microbe cell wall that we have on the plant or in the root zone that's allowing those nutrients to be more available, or creating nutrient cycling so the plant can eat hundreds and hundreds of times a day rather than just the 1 to 5 times you feed it. It's about synergy, and it's about understanding the risk, reward, and costs and cost benefit analysis there too.
Yeah, that's great. And just really quick question from Pat Jacker, just really asking for a little elaboration here about Jesse, your LinkedIn post about the health of the cuticle and the plant waxes deterring powdery mildew. And
So I think it's a little bit different than the systemic acquired response. And the plant is essentially, it has these waxes on it that allow it to photosynthesize and transpire and deal with the external environment. And what I've seen is that, one of the biggest pest vectors is when leaves die. Now, that I believe sends off pheromones from the plant that attracts these negative insects that say, oh, this plant's weak, let's come eat it, right? And at the same time, those dead leaves are a potential habitat for powdery mildew or botrytis. So for me, and this is probably a conversation that might set Rob off, it's about accurately controlling the VPD. It's about making sure that the moisture content in the air relative to the leaf tissue temperature is appropriate. So we're not drying out those cuticular waxes. We want them to remain as long as possible because they're the best defense, especially in late stages against these infestations. So again, it comes back to the tools of the trade. Know how to measure what's in your space, know how to measure the plant, and know how to control so you don't have too much wind or too much heat that are destroying those waxes and making the plant more vulnerable.
Mm-hmm. Jesse, you hit the hot button.
Yeah. No, Jesse, I don't disagree with you. Look, the cuticular membrane is a very important part of plant physiology. Whether it's receptive to VPD or just relative humidity of the air and air velocity, I don't know, right? I don't know enough about the cuticular membrane and what it's sensitive to. That particular article, I get it. There is very good data in that article that Pat's talking about. But, I'm always very sensitive to leaf canopy temperature, right? I didn't see that. I didn't see that touched on heavily enough for my own liking, because whenever we talk about VPD around the office or with anybody, it's how are you measuring VPD? Is it that we saw the chart in that article. That is the one that's very popular online. That's a static chart. VPD changes constantly, and it's different in your entire canopy at different heights of your canopy. You just have to make a best guess with it. Sometimes using the best tools you have. We use the cameras. Other people have different tools, but that's the only thing I would say. VPD is absolutely vital for plant health. If the plant has got lots of vigor, it will be able to fight off all sorts of pests and pathogens. If the relative humidities go off, you look at that chart on one of the slides, it's the relative humidity where you get into the danger zones of pathogen proliferation. So,
yeah, and I would say, we've talked about this and we will continue to talk about this, but I also think VPD is really important for bricks. And if you really want to accumulate more sugars and vitamins and minerals inside your plant tissue, it's important to control transpiration the right way. And if you want to get to a 12 on the brick scale, you really need to make sure that you're appropriately controlling vapor pressure deficit so the plant can take up the mobile and immobile nutrients that it needs and redistribute them appropriately so that you get, a healthy plant from tip to stem to root. So when you do that test, it's reflecting plant health, and VPD is one of the ways to get your bricks higher. And also I would say that this is one thing I think we totally agree on, Rob, whether it's VPD or relative humidity or airflow or whatnot, those cuticular waxes are important. And it's just something that we should think about and consider and talk about how to protect. And that was one of the main things I wanted to put out there by sharing Todd's article was like, hey, let's think about these cuticular waxes. Let's think about VPD. Let's think about humidity and how it plays a role in integrated pest management.
The analog is skin health, right? If you don't have, supple enough skin, if the cholesterol in your skin goes away, which is, a problem with some people, it cracks. And this is an infection zone for your skin, right? That is true for plants. It's true for people. We have to be very sensitive to it. So I get that. I 100% agree. We don't argue about that, I don't think.
Right.
Got it. So plant defenses as an IPM strategy, really building the vigor of the plant as an ability to defend itself against attacks.
Yeah.
Cool. Yeah. Makes good sense. Another one here from Francis is there an IPM strategy for curing?
Yeah, I mean, I think that I think a lot of people don't think about what happens when you cure or the potential for pests. And a really quick aside story is I have a friend whose dad is sick and had grown weed a long time ago, and he had put it away when it was far too wet, and it developed all kinds of problems. It had all kinds of molds growing on it, and when he would smoke that cannabis, he would literally pass out. He would black out and wake back up. And it was, hey, does weed go bad? Or, is there something in these rolling papers that's hurting me? And it wasn't until we really realized, like, there's probably a lot of things in this product that you could have dealt with before you put it in the jar. And if you just would have had an appropriate curing strategy, you wouldn't have the botrytis, the pythium, and the powdery mildew that are all over this cannabis, and it would be safe to smoke. So for me, it's also a thing with my mom. It's like when trying to find safe cannabis early on in the deregulated market, people would sell anything because there was no testing. Now we have testing. It's not just about testing for residual pesticides. It's testing for E. coli. It's testing for salmonella. It's testing for aspergillus. And these are things that it can occur in the curing process. So for me, it's really important to make sure that we migrate the moisture from the interior of the bud to the exterior of the bud in a linear fashion. We don't want the moisture to migrate back in, because then that will trap water inside that will become anaerobic and bring up anaerobic pathogens. In addition to that, we need to make sure that the water activity inside of the buds when we go to finally package them is below 20%. Everyone's got a different signature. Some people in some counties are even testing for this, which I think is really cool. But the idea is that if you put cannabis in an airtight environment with water activity over 20, it's going to sporulate. Things are going to grow in there. And if you can get the water activity below 20, then there's not going to be activity. There's not going to be migration inside the bud that leads to sporulation of these pathogens and pests. And then a lot of people don't filter the air in their curing space. I mean, for years, I would just hang it in my garage and blast it with air and then throw away 20%. Because I'm like, ooh, you get in there, you start trimming away to roll yourself a joint. And you're like, oh, that one's moldy. Let's heave ho on that one and move on to the next one. Knowing that those spores were probably just circulated in the space and without appropriate biological filtration, or just passing them from one bud to another.
Mm-hmm.
Well, I think to that end, moving a lot of air through the room gets that homogeneity of the environment, which gives you some reassurance that every bud in the drying and curing area is getting a consistent temperature and humidity around it to keep the moisture moving in the right direction. So you have to move a lot of air, and if you have the opportunity to move air, you should be cleaning it as you move it. There's no excuse. So, we use a strategy, of trapping with high efficiency filtration, and then photocatalytic oxidation downstream to clean the coil, but also clean the air with the molecular shredders.
And also seal that room, right? I mean, that's one of the physical barriers you can do to create pests and pathogens coming in. I mean, I know people too that have had a handful of spider mites on their plant, and they're like, no, it's pretty good. It's not affecting my bottom line. And then they go to cure, and then 8 days later, we've had thousands and thousands of eggs hatch. And those mites are like, man, I got to eat this really quickly before it dries out. And all of a sudden you're coming in with a vacuum cleaner trying to suck webbing off of buds that you think are going to be sellable. Not going to happen.
Yikes. Jeff had a question here that I think was just addressed about how important particulate control is in IPM and how it's best controlled in cannabis cultivation. If you guys have anything else to add there, please do so.
I think, go ahead, Rob.
No,
I was just going to say, I think it has a lot to do for me about third-party testing data. Like if someone says, I'm going to do this, I need to see the proof in the pudding. So many times I've been misled by people selling a product that hasn't been tested, that hasn't been tried, especially in the emerging cannabis industry. When I had my shop, every day someone would try and come in and sell me something that didn't work. And it was up to me to do the research and find out how it worked, how it would be effective in my facility. Would it synergize with my team and how I go about IPM? What are the costs to deploy it? And, so often people aren't thinking about the facility and the cultivation space as a whole. And all of a sudden people are like, oh, ozone works great. Just pump it into your room and it'll kill everything. And it's like, well, man, I've worked in rooms that are filled with ozone. I've left dizzy with nosebleeds and thought, man, I didn't have to do much in there today because everything was dead. but am I dying too? You know?
Yeah. That's yeah, man, it's a scary thought. And
It's a balance between risk and reward, right? I mean, some radical oxidative species, some stress to the plant is good. Persistent stress is bad.
And stage of development.
Use it to clean the room between plants, sure, but do everything else you can to prevent those oxidative species from oxidizing the terpenes that you're trying to preserve, or oxidizing the THC you're trying to preserve. So, and the cell wall, cell membranes, things like that.
So some of those things might be totally deployable in a cloning and vegetative and mother room space, you know, but not deployable in a flowering space. But at the same time, understand how that's going to affect your other approaches. Is that going to kill the microbiology? Is that going to destroy the Rhizophagus irregularis that's getting you bigger roots faster? Is that going to kill the Glomus mosae that needs 6 months or 6 weeks to develop in order to keep heavy metals in the root zone and prevent them from going up into the plant? These are compromises you might make by bringing in some other sort of advanced filtration technique.
Got it. Okay. Good one, guys. Shift gears real quick. Question from Chris. Can one unit be utilized to control both vegetative and flower stage?
One HVAC-D unit?
I believe so.
Yeah, the answer is yes. It's okay. Yes and no. The difference, there's a distinct calculation that goes along with a vegetative state room and another one for a flower room. And typically flower has got a higher pound per hour moisture removal requirement. The same amount of airflow, if the room's the same size, we'd probably see the same amount of airflow every 2 to 3 minutes. We'd be changing the air in the room. You've got to make sure that if you're going to use one unit, it can handle the highest load in flower and the lowest load in veg. So many times we get into a veg room and the minimum stage on the HVAC-D unit is pulling too much water out of the room and we need humidifiers. I mean, it's crazy, but you've got all this room full of humidifiers, plants, and then you have to add humidification. So our units don't seem to suffer from this problem. We turn down everything, fans to compressors to the energy recovery system. So we can get down to very, very small, zero moisture removal, just complete sensible, and then all the way up to the high latent removal. We can do both, but you've just got to make sure when you're sizing the unit, it can handle both sides of the spectrum.
I think to piggyback off of that too, thanks, Rob, that was great. And what I usually say is, you know, if you size the system for your flower room, then, and it's the same space and the same plant count, it should be able to handle the bedroom. This question also might be bringing up the fact that people want to run one HVAC unit for both their flower and veg. And that's where it gets really tricky, right? Because those conditional set points are so different. The VPD is different for those spaces, you know, for the stage of growth. So you might have to compromise both spaces if you think you're going to run one unit for flower and veg. But absolutely the same unit, if sized appropriately, could do veg or flower.
The key word being there, turn down. So you have to have the turn down ability to handle the veg, the lower load in veg, all the way up to the higher load in flower. Yeah.
Great. All right. Thanks for clarifying that, guys. On a similar line of thinking, Anders is asking, can some of these pesticides, some of the essential oils and other pesticides being sprayed indoors damage HVAC equipment?
Good question. I think the answer is yes. Radical oxidative species will tear up plastics like nobody's business if you've got a persistent amount of them. Usually what we find is they are oxidative to copper, aluminum of some sort. So vaporized hydrogen peroxide, as an example, is vaporized. As long as it stays in the vapor gas phase, we're okay. As soon as it starts condensing and landing on the coils, you may run into problems. So if your coils are running and cooling and pulling out, turning vaporized hydrogen peroxide into liquid hydrogen peroxide at high enough concentrations on the coil, you'll go through aluminum real quick, is my understanding of it. We recommend coil coatings if that is your cleaning the room IPM strategy. So we've seen this come up in a number of different projects, but usually the answer is just don't run your cooling coils while you're doing the room cleaning. The temperatures rise up and allow more of that vaporized hydrogen peroxide to get into the air because you're just vaporizing. So,
Got it.
Yeah, and here's another thing about that. Anytime you're using UV lights, so UV lights can be used as a surface cleaner. We use them as part of the PCO mechanism to create the oxidative radicals with the titanium dioxide mesh. UV light will tear apart plastics. Again, you need to have hardened surfaces, UV hardened surfaces, or metal conduit for all your plastic wiring, plastic sheathed wiring inside your air handling units. And you can get a mile of wiring inside an air handling unit pretty easily. It's one of those things you don't want to overlook because you will start shorting out sensors and start shorting out electrical circuits, and then pop goes a circuit.
And to add to that too, this is actually off topic, but it just got me thinking about what these applications do to the machines in your space, but also to the final product. And, I'd been a big proponent of neem for a long time and different oils just because they mesh with my strategy and they have low impact on the environment and the beneficials. And what I started to learn was that, I might have a product that's considered fantastic, top tier, high grade flower. And then when I put it through the extraction process, there have been extractors that have pointed out to me, it's like, man, I'm getting incredible yields out of your product, like to the point that I don't understand what's going on. And then we dig a little bit deeper and we realize, oh, stylet oil and neem oil are now part of my extract. So just another reason to seriously consider what's going to attach itself to the trichomes, what's going to attach itself to the secondary metabolites, bond with that and carry through. And the casual smoker in low doses might say, man, I love it. It gives it a whole new flavor. Or they might say, hey, I don't, this isn't as great a product, or it might cause more oxidation in long-term storage. Or what triggered it for me was knowing that so many extracts concentrate these applications. And all of a sudden you have heavy metals, you have oils in the concentrate, even though you did very minimal application during the growth stages.
It's wild.
Yeah. Jesse, I want to congratulate you for saying trichomes the right way.
Hey, I get one right every once in a while, man. Hey, get one right.
No, I mean, they'll find
Don't make me say pillow or windmill, man.
You just did.
Ah, crap.
With regard to Andrew's question as well, it makes me think about the quality of your condensate capture as well, right? If you're pulling in all sorts of weird oils and pesticides through your HVAC CD system, what kind of stuff are you capturing when you're condensing that water from the air? And what impact does it have on the ability to recycle that water back into your plants?
That's a great point, man.
Even if you're not doing foliar sprays, let me just throw this out there. You've got a tube with no light in it, so you're not going to use your UV cleaners in the air handler in any configuration to clean inside the condensate drain. Condensate running off of the coil will pick up all this microparticle stuff that's not pathogens necessarily, but it's dirt, and these dirt become these dirt balls, and these dirt balls become nucleation sites for bacteria, and it's hard to get rid of all the bacteria. Anywhere in an air handling unit or in a room like we're talking about. Whether you're doing sprays or not, condensate drain water needs to be analyzed and treated and probably purified in some way, shape, or form before you try and put it back into the room. But just like you said, if any of this oil makes it through the particulate capture system and makes it onto the coil, the condensate coming off is a stream of water that's going to clean off that coil and it's going to end up in the condensate. No ifs, ands, or buts.
No, I like what you're saying. And as a guy who loves to recycle 100% of my water, it's one of the reasons why I sort of steer in that oils and soaps world, because the bacteria and the fungi that accumulate in the condensate drains, I'm okay dealing with remediation through compost tea, through fermentation, through breeding of billions of good microbes that consume the bad microbes and outperform them in a space and an environment in the tea brewer where they're guaranteed to win. The biggest problems for me is like, what else is coming out of that room? How much sulfur is coming into that space? What other acids and chemicals are coming into the space that are compromising my ability to recycle the water and messing up with my tea, or becoming consumed by the microbiology in my tea and then re-delivered to the root zone in a super available way that now is absorbed into the plant. There's a lot of unhealthy things to think about when it comes to that perspective.
Jeez, that's amazing. Lots of interesting stuff to consider. Another one from Andy here. Have you had success getting rid of fusarium in a cannabis grow?
Yeah, I mean, I think a lot of times people see it and they're like, oh man, I'm going to spray hydrogen peroxide. That's my only option. And man, when it comes to systemic fungal colonies coming through the root zone and coming through the water, you need to go back and get cultural control. It's really the only option. You have to treat that water. So maybe it's about getting a water test and understanding what's in your water as it comes in. Just like Rob said, as you recycle it, let's learn about the microbes that are in there. Let's make sure that we, remediate with UV filtration or some sort of treatment, ozone treatment or something in the water, and then have a secondary process to make sure that we're not putting ozone and UV into the root zone. But absolutely, there's some spot fixes that people do. I think a lot of people like to run systemic microbes, get as many fungal and bacterial colonies on and in the plant as possible so they can prevent the uptake of that, so they can filter that horrid water as it comes into the root zone. But in the end, it's a water mold, and you need to deal with standing water in the space, possible drips from condensate lines, filters, leaks, anaerobic water pools. Water, if you clean the room and you push everything into the hallway and you don't clean the hallway, bam, there you go. Water molds in the hallway. Mop sink, water molds. Like any place where water is going to stagnate needs to be addressed. And it comes down to that culture of clean in addition to dealing with the water. And there's almost no point in going in and fighting Pythium or Fusarium in the space on the plant until you get control of the water system. Otherwise, it's a battle you're not going to win.
Right. Yeah, it makes sense. It's attack the source, not don't put a Band-Aid, try and put a Band-Aid on it.
And once you get control of the culture, then your applications to take that Fusarium and Pythium, Rhizoctonia, anything like that out of the picture will be that much more effective, because instead of battling the incoming of new stuff, you've stopped that. And now you can let good microbes take hold, or good chemistry ward off the effects. But in the end, a lot of times I see people go to tissue culture after that experience and they think, oh man, I need to remove the epigenetic material. I need to get back to a stasis. I need to start from a genetic beginning again. So I'm not battling this with the cuttings that I maybe got from my mom, because if you fed your mother plant that same water, now you should think about getting rid of all your mother plants or treating it with systemic bacteria and fungus.
Yeah. Got it. Well, we're 10 minutes over now. So maybe one more or two more questions before we call it a wrap. What do you say, guys?
Sounds good.
Yeah.
Okay. Let's see. Jim is asking, how do I determine if something is a nutrient deficiency or a pest?
Sure. I think a lot of times it comes back down to scouting. So for me, when I walk into a facility, I like to take a look at the canopy as a whole. I like to find plants or spaces that look a little bit differently than the rest of the canopy. And then I immediately go there and address it with my microscope. I look on the leaf surface. I look on the backside of the leaf. I look on the stem. I look in the media. I'm looking for larvae. I'm looking for eggs. I'm looking for bugs. That's always my first spot, let's find the pest that's killing this. If I can't find any pests, if I can't find pustules, if I don't see the black dots, the initial formation of powdery mildew, then I think of fertigation as the remediation. And I think, okay, what's going on? Is this emitter on these group of plants working right? Are we delivering the appropriate amount of nutrition? Do we have a nutrient lockup? But for me, if you go through those steps and you can't identify a pest on the plant or in the space, then it's probably nutrient or environmental related. So go back, change your fertigation schedule, think about what that might be, what might have caused that, try and link that up with some pictures you see, and get a balanced delivery of fertigation back to the plant. Or what I would do is say, come heavy with seaweed, because it'll trigger systemic acquired response and it'll be a bunch of micronutrients to help your plant recover as quick as possible.
If you're losing emitters, a good control system is going to tell you that, right? If you're tracking, like we do, moisture removal across the course of a day, and we're stacking it on day, we know if we're getting to the end of the cycle and the water transpiration rate starts to fall off, that it's probably an emitter problem or some sort of watering problem. So that would be the first place to look, and we alarm off that on our control system. So I think there's ways to just kind of nip that one in the bud if you've got a good control system. I'm not sure about the other ones.
Yeah, and a lot of times, like, it just ends up being, depending on your fertigation, it's a salt buildup or a buildup in the lines or glomulin or something preventing that plant from getting the appropriate dose of nutrition. On the large scale, that tends to be with a professional fertigation approach, that tends to be like the number one problem. And then we can go ahead and take a look at changing the dose. But if the rest of the canopy looks good, isolate that space, isolate that plant. Think about what's specifically wrong with the controls, the physical and cultural space for that plant.
Yeah, and Pat makes a good point about identifying the damage to the plant tissue as being a good way to tell if it's a pest.
That's a great one. Like, in a lot of ways, I can spot a pest from a few feet away. If it's speckling on the top side of the leaves, depending on the size of the speckling, I'm like, oh, you have mite issues. You see the lines in the plant, you've got some sort of leaf miner. If you've got a big juicy bud outside in one little brown spot, you've got caterpillars. Go quickly, spray some Bacillus thuringiensis, spray it in the morning so it has time to work and not be affected by the sun. Release some trichogamma wasps. Think about the local hatch rate. There's a lot of stuff you can do to sort of take a look at the damage and get a really good idea of what's going on due to the damage. Because you might not always find a pest. Pat's actually absolutely right. But if you do see the damage, that's just another sign and indicator of what's going on in the space.
Yep. Perfect. All right. Final question here, and we can call it a wrap. What are the advantages of PCO over UV? And also HEPA versus MERV 13 versus MERV 8?
May?
Please.
So, as I mentioned before, we use UV in PCO. It is activating the titanium dioxide catalytic reaction to disassociate water molecules in the air, create these OH negative hydroxyl radicals. And for that 8-inch window, we are creating a very highly oxidative airstream, 8 inches just downstream of our cooling coil, that anything running through it in that 8 inches, it's enough exposure to the oxidation to basically shred the molecular shell, the casing on a virus or a spore. It'll even tear apart VOCs and odors and things like that. So that's different than UV. So UV light requires a dose over a long period of time. UV is a good surface cleaner, but if I'm going to try and get a particle of air that's traveling at 500 feet per minute through my air handler and 1,100 feet per minute through my duct, I need 40 feet, 60 feet of UV light at a high intensity throughout that entire piece of duct. Now, again, UV light, great surface cleaner, not so great particulate killer or particulate disabler because you just need so much of it. We know those systems are out there. If that's your preference, fine. But I don't understand what the maintenance costs associated with having such a high intensity UV light, changing the bulbs all the time, having access into that ductwork. I just see it being problematic. That's the difference between UV and PCO. So I hope that made sense. In terms of filter, particulate filtration, HEPA, MERV 13, MERV 8, the lower you go, so HEPAs are MERV 16, HEPAs are MERV 16 plus, MERV 13, and then MERV 8. The lower the number, the more of the smaller particles are going to get through. A MERV 13 is not perfect at capturing all of the particulate that we want to stop, 1 micron and above, but it does a very good job of it. HEPAs, there's a balance point here. You're going to spend a lot more energy moving air through a HEPA filter, which has just got smaller holes, which is why it's doing so much more particulate capture than you are in a MERV 13 filter. And also, MERV 13 equivalents or HEPA equivalents with have the lower pressure drop, and we prefer to use those instead. It's a balancing point. I never recommend MERV 8. They're a sieve to the things that we think are a problem. MERV 13s do a really good job, and with the PCO downstream doing the coil cleaning and the airstream cleaning, I think we've got a pretty good 1-2. It's a good balance between energy consumption and air cleaning. Sure.
So I know that was supposed to be the last question, but when we announced this webinar, I got a handful of questions from legacy growers, from my friends in the industry, from people that asked me if I was going to sort of tackle the conversation about microdosing. And I think it's an important thing to talk about, right? When I first heard the term microdosing, it was, I immediately thought, yeah, sure, do some mushrooms and go to work, man. You might be more creative. Sounds like a great idea to me. But then I realized that my friends were talking about, microdosing, Eagle 20 and Tetrasan and Forbid and Merit WP and these banned substances. And I came from an industry where we had to use what was available. There was a lack of regulation, there was a lack of study, and there was a lack of knowledge. So we grabbed for the things that were commercially viable in commercial agriculture, and we utilized them. And if you utilize them inappropriately, there are huge consequences. Yeah, you'll fail a test, you'll have to destroy product, it'll be a brand black eye. You might pass a test when it comes to buds, but then you're going to fail a test when it comes to concentrates. But here's my real cautious tale here. I've been growing cannabis for a really long time. And before I knew any better, I used banned substances. And then I decided that I was going to have a family. I've been with my wife for over 20 years, and it was really, really hard. And I couldn't figure out why it was so hard. We were trying so much, but we weren't having kids. And what I realized was maybe it has something to do with this stuff getting absorbed into my skin, into my body. What are these systemic pesticides doing to me as a person? So I completely stopped. I got away from every pesticide that I did not understand, everything that I thought may or may not be banned. And 6 months later, my wife and I had our first kid, Miles.
What?
So to me, yeah, you do whatever. It's a personal choice. It's a business choice. But in reality, there are consequences that you might not be thinking about. And that's just my personal story. So it doesn't resonate with everybody. But the reality is, I think that is the reason why we were unable to have children for so many years.
A pretty good ending.
Wow. Wow. Thanks for sharing that, Jesse. I hadn't heard that before. That's pretty wild. Makes you wonder what the impact it has when you smoke it. Yeah, right. A flower with banned substances.
Talking about oxidation, like you turn these chemicals into, awful carcinogens, and
yeah. Well, hate to end it on that note. You guys want to tell a joke before we sign off?
IPM's not a joke, Brian.
Nothing I want to webinar on YouTube for the rest of that history. So.
Yep. Got it. All right. Fair enough. Well, hey, great job, guys. Thank you very much for your time. Thanks to everybody who was in attendance today. Our website is up on the screen. If anybody would like to get in touch, please feel free to do so. We're here to talk with you about IPM and HVACD, and always love to have those conversations. On that note, happy Thursday, everybody.
Thanks, everybody.
Next time.